Okay, so just finished quiz 9.2, hopefully. We're going to correct assignment number 1, and then we're going to go on to explain the lab for next time, and then I'm going to have you do some write-up. So, let's get out your assignment. What we're going to do today is we're going to design a lab to investigate the factors of reaction rate. Who can remember what the factors of reaction rate were? Particle size, surface area, catalyst, concentration, and the nature of reaction. Now, we're already going to have the nature of reactions, so we're going to know that they do react. So, we're looking at your lab now. This is a lab day. You'll notice that there's no other assignment other than finishing your pre-lab. Okay, it is a pretty big pre-lab. So, let's read a little bit about this first, background. So you're following along with me on your paper. Rates measure change that occur within intervals of time. For example, if you travel to a city 300 miles away in 5 hours, your rate of travel would be 60 miles an hour. Basically 300 divided by 5. Instead of units of length, miles, and time, hours, reaction rates are expressed using chemical units, moles or grams, and time. An example of units on a rate would be a small sheet of metal containing a mole of iron. Might rust at a rate of 0.5 what? Well, if we look at a mole of iron from the periodic table, that would be 55.845 grams. So about 56 paper clips, okay? So think of that in your head, about 56 paper clips. How fast would that rust? Anybody have an idea? That 0.5, what should I put as, well, we got moles for sure, but what should I put it for as far as time?
Days.
Moles per day, okay. Think it'll rust real fast over a day?
Depends on what's being like heat being added.
Okay. So I've got cast iron pans at home. What it's being exposed to, good. So what on average do you think it would be? I would probably go months or weeks. Okay, what do you want to do?
Weeks.
I got another one for weeks. How many say weeks? Okay, we'll do weeks. Okay, so if I leave my cast iron pan out, it's probably not going to rust right away, but if there's a little water around and I'm not taking care of it, don't oil it, it's going to rust. So what you're going to be doing is you and your partner, and luckily all partners are here except the 2 that aren't here are partners, so they'll have to do it back when they get back. You'll be performing 3 different experiments. You get to decide as your partnership what experiment you're going to test what on. We're going to do particle size, concentration, and particle size temperature. Okay? I'm going to show you the experiments. I'm going to let you talk with your partners, and you're going to decide, and then you're going to write it up. Okay? So for each experiment, you need to have a dependent variable and an independent variable. The dependent variable is what you are changing. Okay, so dependent variable, what am I changing? Independent variable is the thing that changes because I changed the dependent variable. So if I change the particle size, then does the time increase? Kind of thing. Okay, so there's that. I just told you what we'll be testing. You can't heat acid directly, so you're going to have to put it in an ice cream bucket lid is what we're going to use. So you can put ice on the ice cream bucket lid, you can use warm water, you could just set it out to the side. So you have at least 3 to 4 tests, okay? But we're going to use the ice cream bucket lids. Particle size, you need to be able to cut it smaller or grind it up. Some reactions are better than others for individual experiments. Think through your choices. So, since we're going to be working in partners and I'm going to be doing the rest of this together, would you guys squirt together as partners so you can talk? And you guys maybe come up onto 1 or 2 so you guys can talk on the side because you're all one group. Okay? You'll notice on the bottom right-hand side, on the bottom right-hand side, there is a place where you can put concentration, particle size, and temperature. And as you look at these, write down what you think and then talk to your partner. You guys going to work together? Okay. All right. So the first one I'm going to show you is about reacting sulfuric acid and sodium sulfite. We're going to do that in a Petri dish. That's my best drawing of a Petri dish, and it's on a plastic plate. When those two react, they actually produce sulfur dioxide. And we're going to put an indicator in there that will change colors when the sulfur dioxide is produced. Okay? So this is the reaction. Nice thing is, for two of them, I gave you the reaction. So when it asks for the reaction, you just have to write it in. Okay? So let's look at this one real quick. I'm going to stop the video because it doesn't like live. Okay, so I messed up earlier. Dependent variable is the one that changes because of it. It is in your note, in your pre-lab. It tells you which one's which. IV is what you're changing. So independent variable is what you're changing. Okay, so we actually experienced this, and you got to see that the indicator on the lid stayed green and the indicator inside turned bright orange over time. So you can adjust the number of drops. Remember, if you're going to do concentration, it has to be a specific amount of drops that you have total in there, like 5 or 6. Don't go above 6, because you gotta put that lid on fast. Okay. Next what we're going to do is reacting magnesium ribbon with hydrochloric acid, and this one's done in a well plate. You'll also have some water that you could do, so you could dilute the hydrochloric acid with water. Don't dilute it more than half, or you'll be there forever. Okay? You could do particle size, because you can cut the magnesium ribbon up into small pieces, and you could also take and put it on ice or whatever. Okay, so let's look at this one. Okay, so for the next one, we're going to be using reacting seltzer tablets with water. We're going to do them in film canisters. The bad thing is we're going to do them on Friday, and there's supposed to be a big storm, and we have to do them outside. So you guys might want to bring something that you can be outside for about 15 minutes with. Okay, just FYI. The seltzer tablets are made of citric acid and aspirin and sodium bicarbonate, and that, oops, I need to fix that. That should be capitals. It will form sodium citrate, water, and carbon dioxide. You'll be given one tablet and need to perform a minimum of 3 tests. I'm going to tell you do 4, because you really can't tell a trend unless you've done 4 experiments. Okay? 3, if one of them's bad, you can't tell what's going on. So do 4, because you might have one experiment that goes awry. Okay? And it doesn't take that much more time to do one more experiment. So this is what we're going to do. Okay, I'm going to pause this again. Well, actually, let's talk about it first. So you're going to have a film canister. On the side of the film canister, it'll have marks. Most of them have a 1/4, a 1/3, and a 1/2 as the marks. This one has a 1/4, a 1/3, and 3/4. But you're going to pick one of those marks to fill up with water. This one is really hard to use for concentration. Okay? Because you would have to vary the amount of water or the amount of particles that you put in there. I guess you could do it, but it's just not as nice. When I give you a tablet, you're going to divide it into 4. So everybody's going to get one tablet. You can divide it into 4 and do 4 different experiments. I actually probably will give you one of these. So you could use a 1/2 on each of them. But you could use only a 4, so if you use less, that's fine. You're going to use a film canister, and we're going to see how high it goes. So on this one, we're not only going to be measuring time, but we're going to be measuring height in bricks outside. So you'll need to go, and I'm hoping the snow hasn't covered it by then. If not, we're going to have to use just that pillar just outside the doors. But if you go on the Mow strip in front of one of the bricks that goes all the way up, not in front of the windows, you can count real fast. Okay, so and we'll go forward a little bit. Don't need my goggles now. Okay, so between you and your partner, decide on what you would like to do for, I think, turn the page to the first graph that looks like this for a minute. Tell me what it says on the top. concentration, excuse me, oh, that was awful. Okay, so I want you to talk to your partner and decide which one you're going to use for concentration, which one you're going to use for particle size, and which one you're going to use for temperature. And that will be on the page before this that you write that. Okay, so figure it out right now. I'm going to give you 1 minute. Yes. The equations for the most part are already, just use them as is. The only one that you're going to have to do yourself is the magnesium with hydrochloric acid. Yes. No, 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 no. We're going to do all three. I'm just going to walk you through one of them. Okay, you got about another 30 seconds. Make a decision. So you're actually making a decision on the next page. Right here. Yep. So this is on the second page. You're putting your decision down. Okay, make sure that you got your decision down. Okay, then what you're going to do is you're going to write on the first grid that looks like this. So turn to the first grid that looks like this. Make sure it has concentration on it. Whatever you decided for concentration, that's what you're going to put for the balanced equation. The only one that doesn't have a balanced equation that you have to write yourself is the magnesium and hydrochloric acid. So magnesium is Mg plus what's hydrochloric acid? HCl. It's going to be a single displacement reaction. So it's going to make, hydrogen's going to be kicked out by magnesium. So it's going to make magnesium chloride. What's the charge on magnesium?
1.
Plus 2. What's the charge on chlorine? 1. -1. So you're going to need 2 chlorines to go with the magnesium, plus hydrogen. And don't forget, hydrogen's one of the Braunhilfels. And then you'll need to balance it. Okay? All right, so whatever you're using for concentration, if it's the first experiment with a Petri dish, or if it's the second experiment with magnesium, or if it's the third experiment with the Alka-Seltzer, put the balanced equation in there right now with me. Put the balanced equation in there. So is it A, B, or C? Okay, you've got the equation in there. It should be on the front page if you're and the only one that's not is, like I said, the magnesium and hydrochloric acid, because I want you to practice writing the equation again and balancing. And we sort of walked through that, so if you're having problems, you can do that. So Mg plus HCl yields, they switch partners. Magnesium goes with chlorine. Magnesium has a +2, chlorine has a -1, so you need 2 chlorines. Plus hydrogen goes by itself, but it's one of Braunhilfel. Then balance it. Nope, in the front. You don't balance down below. MgCl2 on the and H2 on the product side with HCl and magnesium on the right on the other side. So they have to have the same amount. I can't all of a sudden, boom, here's 2 chlorines and I only had 1 on the other side. Okay, so you've got your equation. Everybody done with your equation? I'm going to walk you through one of them so the others 2 will be easy. So the problem, all you have to do is to reword the first thing. What is the effect of concentration on reaction rate? And I ran out of room, sorry. Done. Okay, so all I did is reword what was up at the top. Now you're going to have a hypothesis. What is a hypothesis? Educated guess. What do you think is going to happen? Is it going to go faster? Is it going to go slower? When is it going to go faster? When is it going to go slower? Write an educated guess down. When? Got to tell me when. Faster when? Okay, yes?
So for a problem, do you put And then you put that.
Whatever you're testing, yeah.
Reaction rate, you put that every time.
So what is the effect of what on the reaction rate? Okay? All right, so you've written your hypothesis. Everybody there? Okay, now we're going to IV. That is what are you changing? So what thing in your experiment are you going to change to affect the concentration? Okay, what are you trying to change to affect the concentration? So what are you going to manipulate? What are you going to change things to make the concentration different? Yes? The green stuff was universal indicator. And that was just to tell me when the reaction was over. So that's going to be one of my constants, if you're using that one. What I'm changing is how many drops of sodium sulfite and how many drops of sulfuric acid, if you're using that one. Okay? So dependent variable would be what is changing because I'm changing this. Well, we're going to be timing everything. So for the most part, it's always time. Right? If I'm using the Alka-Seltzer, though, I'm going to put time and Brix there, okay, or height. What was held constant? Okay, what did you not change? What thing is going to be the same in every single experiment? Write that down. Okay, so for instance, I'm using one well plate. I'm using this many drops. I'm using this Petri dish. It's not going to change. I'm using universal indicator, whatever's the same. Write down whatever's the same. What's going to be the same?
I think reaction is going to
So what things in the reaction are going to be the same? So what experiment are you doing? Magnesium?
Yes.
So you have to use the same amount. Nope, you're doing concentration with magnesium. Yeah, you're going to have to put the same amount of magnesium in each one. You're going to have to change the amount of hydrochloric acid versus water. Okay, everybody done with that part? We should finish that. What's constant? We put what's changing. What did we change? So, yep, so this would be hydrochloric acid and water. Okay, so for the procedure, this is a part that people have a lot of hard time with. So before I do my procedure, go to your data table. What things do you want to do? So in the first column, put trial above and say 1, 2, 3, 4. So you're going to do 4 trials. Okay? That will help you because this is going to become your x on your x-axis for a graph. Okay? For all your graphs. That's going to be your x-axis. Then I'm looking at my experiment. What do I need to, or what's going on? If I'm changing number of drops on each one, maybe I'm doing the magnesium where I'm changing the concentration of the hydrochloric acid. Or maybe I'm doing the Petri dish where I'm changing the number of drops of the sodium sulfate and the sulfuric acid. Or maybe I'm working with Alka-Seltzer and I'm changing the amount of water or the amount of Alka-Seltzer I put in. I'm going to put that right here. So for instance, if I'm doing hydrochloric acid, I would do hydrochloric acid and water. And I would put how much I'm going to put in each of them, remembering that I don't want to go less than half of the total volume with hydrochloric acid. So say I've picked 40. I could do 40 and 0. I could do 35 and 5. I could do 30 and 10. I could do 25 and 15. Okay, so I show on my data table what I'm changing. So whatever you're doing, do that. Okay, give you a few seconds to get that figured out with your partner. If it says molarity, then when you go back in lab, you're going to get the molarity off the thing here. Okay?
We're not actually going back in the lab.
Not today, next time. So we got to figure it all out before we go back in lab. Okay, is everybody, whoops, I forgot to put the R on water. Okay. So So for each trial, that tells me how much hydrochloric acid, how much water. So total volume there would be 40. So if I'm doing drops on the Petri dish, maybe I want my total drops to be 5 or 6. So I do 1 drop of this, 5 drops of this. So it always adds up to 6. Okay? So concentration, you can't change the total amount that you have, but you need to change the amount of each one. Okay? All right, we okay?
So how many trials are there?
4. Okay, so the last one, what am I going to be measuring? Time. So my last column here is time, and this is going to be my y-axis. Okay, so now that I've got the table set up, it makes it a little bit easier to do the procedure because I can say in my procedure, collect all the things that are needed and list them. I can say, set up trial 1. I can say, get magnesium strip, split it into 4 equal pieces. And I can say, drop the magnesium strip into the well and time. Then repeat for 2, 3, and 4 steps, whatever through whatever. Okay? You need to make sure that this procedure, this is the part we're really looking at, hint, we're really looking at this, is clear, and you could hand it to somebody else and they could do the experiment without having to ask you. Yes?
What happens if we get the hydrochloric acid?
And you're going to wash underwater for 15 minutes.
Oh.
But I put them in droppers, so hopefully you won't. Okay? So, you're going to do this for each of them. Okay? Set up your graph. So right now we know what's along the bottom. Trial number. So I can set it big or wide. I can do this as a bar graph. I can do it as a line graph. What about on this side? What's on the y-axis? Time. So I can already put time, but I don't know how to divide it yet because I don't know what my results are going to be yet, right? So I'm going to wait on that. But I could put trial 1, 2, 3, 4, and make it as big as I possibly can. Okay? So don't give me an itty-bitty, teeny-weeny graph. Use as much as you can. Now, here's a hint. If you're using, when you use the film canister one, you're going to have 2 graphs. So you're going to have to split this in 2. One of them is going to be time, and the other one is going to be bricks or height. Okay, but they'll still have trial on the bottom. Okay, everybody understand that? Okay, once you've got them all done, bring up to me with your partner your labs, and I will check them off. Please hand me the one that writes the best so I can read it. Okay, and then once you got it checked off, you're all ready to go into lab next time. Questions? Okay, time's yours. Get it done. No, you're doing them right now. You're writing them down right now. You're going to actually do the lab next time. Okay? So you got to have your procedure written down because it's still fresh in your head what's going on. Right? Okay, any other questions? You have to write the procedure. You have to write the procedure.